This video is a supplement to the discussion of compressibility factor in Lecture 1 of Topic 4. Reduced pressure is defined as PR equals to P over PC, where P is the pressure of the system and PC is the critical pressure of the component. Similarly, TR, reduced temperature, is equal to T over Tc. We can write an equation of state for real gas as PV equals to Zn RT, where Z is the compressibility factor. Z is a function of PR and TR, and we can read Z from charts that we will see two of them here. This is one chart. The horizontal axis is PR going from 0 to 1, and then on these curves each one of them belong to a value of TR. Here is TR of 1, here is TR of 1.05. Note that at a very low value of PR, the value of Z is equal to 1. If we look at the PR relation, P equals to P over PC, PR becomes very low and approaches 0 when value of P becomes very small, much less than PC, so that this fraction approaches 0. Recall the PT diagram that we have seen before, and we said that the pink region is where gases behave ideally. This area here is when P is very low, as you see, and therefore in this region Z will approach 1 and we have ideal behavior. Moreover, look at these numbers on these lines. The top one is TR of 5. So if I have TR equals to T over Tc, and if this is 5, it means that the temperature I have is 5 Tc, which is a very high temperature. Again, look at the diagram, and if we really have to have high pressure, the only chance of having ideal behavior is around very high temperatures. It means that in this region, again, Z may approach 1, which means ideal behavior. In this chart, PR goes from 0 to 1, and there is another chart where PR goes from 0 to 10. So if you have a value of PR which is between 0 and 1, although you can read it from this chart, but the previous chart is better and more appropriate. Another thing on this chart, look at these values. Very large TRs, it means that beyond this area. Another part of this chart just for bigger TRs. Suppose in a problem I have a pressure and temperature and I know what is the component there. I am gonna go to the tables and get the PC and TC of that component. Then I am gonna calculate PR equals to P over PC and also TR equals to T over Tc. So with the value of PR, I am going to go up here until I get, for example, the value of TR of 1.5, and I can locate a point there, and horizontally I go and read the related value of Z from the chart.